Everyone, I'm Cyrus and I teach ONA level physics. My session for May-June 25 examination is going to start from 15th of October for O-level, IGCSE, AS level and A2. It's going to be a comprehensive, detailed 5-month session in which we're going to get a lot of practice from past papers, assignments, worksheets and quizzes. So what are you waiting for? Register via the link in bio and our team will assist you in registrations.
ये जो मैंने आपको फॉर्मूला बताया है ओमेगा इज इक्वल टू 2 पाई बाय टी का, दैट इज प्रिसाइसली 2 पाई ओवर कैपिटल टी, एंड यू कैन आल्सो राइट इट एज 2 पाई एफ. एफ यहाँ पे लीनियर फ्रीक्वेंसी है, ठीक है. सर्कुलर मोशन में ओमेगा एंगुलर स्पीड होती है. सिंपल हार्मोनिक में जब हम पढ़ेंगे it will be angular frequency. There's another thing that you should know, that if V is equal to R omega, then V can also be written as R omega की जगह हम लिख सकते हैं 2 pi by T. If this is true, this becomes 2 pi R over capital T. ठीक है, तो ये असल में ये वही चीज है. V is 2 pi R is the circumference and T is the time. तो speed is distance over time वाला फॉर्मूला यहाँ पे यूज होगा. अगर आप गौर करें तो इसका सर्कमफेरेंस होता है 2 पाई आर, और अगर आप इस पार्टिकल जो है वो ट्रेवल कर रहे हैं अराउंड दिस सर्कल एंड यू डिवाइड दिस 2 पाई आर विद कैपिटल टी, यू गेट व्हाट यू गेट, v. अच्छा, एक और फॉर्मूला है, दैट इज v इज इक्वल टू 2 पाई, और को अगर आप यहाँ पे 1/t लिखते हैं तो दिस कैन बी ऑल्सो इन अ मूविंग डिस्क विच इज मूविंग विद अ फ्रीक्वेंसी. ये सवाल आ सकता है, ठीक है, कि फ्रीक्वेंसी f है और उसकी स्पीड फाइंड करें. यू कैन राइट दिस फॉर्मूला 2 pi rf, right? This can be another question that we have. Let us talk about the centripetal acceleration. You should know that if an object is moving in a circle, let's say this object is moving here in a circle, even though it is moving in a circle, it's changing its direction at every instant, although it can be moving at a constant speed. But what's happening is that the direction is changing, so it will be accelerating. I'm going to write here that an object, even though moving at a constant speed in a circle will be accelerating. And the reason for that is since its direction of velocity is changing. Direction of velocity is changing every now and then. This is, you see what's happening is that this is velocity is changing, right? Speed constant है लेकिन velocity change हो रही है क्योंकि direction change हो रही है. Speed हो सकता है constant हो, उसमें कोई मसला नहीं है, लेकिन direction change हो रही है तो velocity change हो रही है. ठीक है? You should know that a changing velocity over a certain time gives acceleration. The direction of the acceleration is always towards the center. Okay? And there is a reason for that because of these vectors. Head to tail rule लगने की वजह से the direction of the, I'm going to write here that a changing velocity over a certain time gives an acceleration. The direction of the acceleration is towards the center of the circle. अच्छा, अगर आप थोड़ा गौर करें तो फॉर एग्जांपल मेरे पास यहाँ पे एक ऑब्जेक्ट था दैट इज एट पॉइंट ए, ठीक है, और यहां से उसकी वेलोसिटी थी va, राइट? मैं अब आपको असल में प्रूव करना दिखा रहा हूं कि एक्सेलरेशन सेंटर की तरफ कैसे होगी, because this is VA and let's say at this point somewhere here the velocity is VB. This VB is basically the resultant velocity. मतलब एंड पे आ गई है ना बिल्कुल, तो उसके दरमियान में भी कुछ हुआ है. Something happened in between as well. If this is the center of the circle and I put this here, right? This VA here, right? This is VA. इसको थोड़ा सा इस तरह बना देता हूँ. Suppose VA, अच्छा अब ये इस तरह से है. तो अगर मैं हेड टू टेल रूल अप्लाई करूं तो समथिंग इज हैपनिंग लाइक दिस. यहां से वेक्टर एक आया, ये वेक्टर था Vx. इस वेक्टर Vx का हेड VA की टेल के साथ ज्वाइन हुआ. देखिए VA एग्जैक्टली यही है. दिस VA is exactly here. I've just put this here. VA is going to join with Vx is going to join with VA. Okay? The head of the first vector will join with the tail of the second vector, and the tail of the first vector will join with the head to give you the resultant. So VB is your resultant, right? So what's happening is in vector terminology, Vx is vector 1, which is joining with VA, and that is giving you a resultant which is VB. अब अगर आप थोड़ा गौर करें, Vx की डायरेक्शन सेंटर की तरफ है. Can I write here Vx is equal to VB minus VA? Can we do this? We can. And the direction of Vx is here, and Vx is what? Vx is the change in velocity, isn't it? Vx is the change in velocity, right? I can divide both expressions with delta t, and this expression here is giving us what? The acceleration. So this confirms that the acceleration is in the direction of Vx, which is the change in velocity over time, right? ठीक है, तो आपकी जो एक्सेलरेशन है सेंटर की तरफ, देखिए Vx सेंटर की तरफ एक्ट कर रहा है, तो आपकी एक्सेलरेशन जो है वो देखिए सेंटर की तरफ एक्ट कर रही है. We know VB is the resultant because this is something that came after VA. VA was initially the first one. Some intermediate steps took place, and we are getting the final velocity as VB. This is the final velocity. This is the initial velocity. Something in between also went on. That's why we know that VB is the resultant velocity. देखिए VA आपके पास ये है, right? This is VA, this was VB. तो दरमियान में Vx involved है. असल में ये बताना मैं चाह रहा हूँ कि आपके पास एक्सेलरेशन की डायरेक्शन सेंटर की तरफ क्यों होती है. ठीक है, VA is here, VB is here. VA देखिए VA स्टार्ट हो रहा है, उसके बाद ये पार्टिकल यहां से यहां जा रहा है. VB is the final velocity, and that is the end. This is the end that we have. तो अगर मैं इसका हेड टू टेल रूल बनाऊं तो ये देखिए हेड टू टेल रूल बन रहा है. ये Vx है, ये VA है और ये VB है, right? This is Vx, this is VA, and we are getting VB as the final step. If there was a VC तो फिर अगला वाला आ जाएगा, वो आगे आ जाएगा, वो फिर यहाँ पे यूज हो जाएगा. VC अगर यहाँ पे यूज हो रहा है, if VC is here तो आप VC को फाइनल ले लेंगे, VB को इनिशियल ले लेंगे, right? It goes on. The acceleration is always towards the center of the circle. Moving on, you should know that the centripetal acceleration is always towards the center of the circle. इसकी जो डेरिवेशन है वो रिक्वायर्ड नहीं है आपको, ठीक है, लेकिन इसका फॉर्मूला आपको आना चाहिए. The formula for the acceleration, which is the centripetal acceleration, is if we have an object in a circle and if v is the linear velocity, a is the centripetal acceleration, r is the radius, then acceleration is v square over r. Acceleration is v square over r, where v is the linear speed R is the radius of the circle, and A is the acceleration. We can also write it like this: A is equal to V square over R. There's another formula for the centripetal acceleration. Since you know that V is equal to R omega, you know that V is equal to R omega, we can put this expression here in V square over R, and this becomes R omega whole square over R, and this becomes R square omega square over R, and this becomes R omega square. There's another formula for the centripetal acceleration. One is A is equal to V square over R. The other one is A is equal to R omega square. Here R is the radius and omega is the angular speed. ठीक है? तो ये दो formulas मैंने आपको बता दिए, right? ठीक है जी, ऑनलाइन स्टूडेंट्स आप लोगों को भी क्लियर है? बख्त, मारवा, मीरब, मुस्तफा, सुलेमान, जोनिया, रीच, अलीना, अयान, अशर, everyone. Okay. A is equal to V square over R and A is equal to R omega square. ये दो important formulas हैं. एक और चीज वो आपसे पूछ सकता है, right? और वो ये चीज पूछ सकता है that show that A is equal to V omega. We can use the formula A is equal to V square over R for this, right? आप इसको यूज करके शो करें that A is equal to V omega. ठीक है, आप इसके अंदर वो पुट कर दें, V is equal to R omega पुट कर दें. उसके बाद ठीक है, अगर आप R को सब्जेक्ट बना लें, this becomes V over omega, क्योंकि हमने R को एलिमिनेट करना है. अगर हम R को सब्जेक्ट बना लें, we can put this here, and this becomes V square over V over omega. Can we do this? And this becomes this cancels with this one. This will come upstairs. And this becomes V omega. ये आप इस तरह से भी कर सकते हैं, V square divided by V over omega, which is this cancels with this one, and you get V omega. तो ये इस तरह से आप लोग इसको जो है वो करेंगे. ठीक है, ये हमारे पास डिफरेंट फॉर्मूलाज बन जाते हैं फॉर centripetal acceleration, which is towards the center of the circle. ठीक है, acceleration का ये समझ आ गया सबको? There's another thing that you should know. I'm going to talk about centripetal force, right? Centripetal force क्या होती है? Centripetal force is towards the center of the circle, and it has the same direction as that of centripetal acceleration. So we have centripetal force here, and remember that even if we have a circle like this, and this object is rotating all the way, this is the direction of the acceleration. आप लोगों को पता है already that F is equal to ma. You know this. You know this, that F is equal to ma, and the direction of the force will also be in the direction of the acceleration. So if we substitute the formula of acceleration, which is V square over R, we get the value of the force, which is mv square over R. So we get another formula for the force as mv square over. I could have used R omega square, and that would have given me omega square R. Okay. So F is equal to m omega square r. That is also fine. ये भी बिल्कुल ठीक है. या तो मैं ये अब डिपेंड करता है मेरे पास क्या इंफॉर्मेशन में गिवन है. अगर मुझे लीनियर स्पीड नहीं गिवन, ओमेगा गिवन है, तो मैं यूज कर सकता हूँ. ठीक है. या अगर आपको आर गिवन नहीं है तो आप ये भी यूज कर सकते हैं. अगर आप करना चाहें तो इसमें कोई मसला नहीं है. ये वैसे ये यूज इतना नहीं होता, लेकिन फिर भी अगर आप ए की जगह लिख दें वी ओमेगा तो ये भी ठीक है, गलत तो नहीं है. एफ इज इक्वल टू एम वी ओमेगा. That is also, fine. But these two will be used much more often. And this is very much rare, mv omega. This is, by the way, v. This is not r, remember that. This is mv omega. This is mv omega, right? This is the velocity. एक बात आप लोगों ने और याद रखनी है हमेशा. Centripetal force is always and always the resultant force. ठीक है? We can have a number of forces acting in a circle, but the centripetal force is always the resultant force. Remember that. Centripetal force is always the resultant force. So for example, we have something like this. And if an object is moving in a circle, there would be, ये अभी हम आगे पढ़ेंगे vertical circle को. इसके अंदर हो सकता है स्ट्रिंग के अंदर टेंशन होगी और ये ऑब्जेक्ट का वेट होगा. तो हम क्योंकि ये ऑब्जेक्ट टूट नहीं रहा और फोर्स रिजल्टेंट सेंटर की तरफ होती है, तो हम इसको पढ़ेंगे आगे that T minus mg will be equal to the centripetal force, और centripetal force की जगह हम mr omega square. We'll see this, right, in much more detail, right? But this is the thing that is very, very important, that centripetal force is always the resultant force. आपके पास एक ये क्वेश्चन है जो आपका ये नॉलेज जो है वो रिफाइन करता है. एक फ्लाई व्हील है जो 600 रेवोल्यूशंस पर सेकंड पर मिनट पे मूव कर रहा है. 600 रेवोल्यूशंस पर मिनट. ठीक है. एक ऑब्जेक्ट है, वो 600 रेवोल्यूशंस जो है, ये रिम ऑफ द व्हील समझ लें. इसका रेडियस है 20 सेंटीमीटर्स. Radius is 20 and its object is making 600 revolutions per minute. आप लोगों ने ये बताना है what is omega, what is the linear speed, and what is the centripetal acceleration. ठीक है. आप 600 revolutions को 60 seconds में अगर देखें तो एक सेकेंड में जितनी रेवोल्यूशंस हो रही हैं वो उसकी फ्रीक्वेंसी है. 600 रेवोल्यूशंस हो रही हैं 60 सेकेंड्स में. ऐसा हो रहा है कि नहीं हो रहा? एक सेकेंड में आपके पास 10 रेवोल्यूशंस हो रही हैं. This 10 rev is 10 hertz. I mean, 10 revolutions in 1 second is 10 hertz, isn't it? So if you want to find omega, omega is given by what? 2 pi f. So you have 2 pi, and the frequency is 10. You get the answer 20 pi. 20 pi is, and the units for omega are radian per second. What is V? V is equal to R omega. R is what? आपने ओमेगा निकाल लिया ऑलरेडी. ठीक है. और 2 pi RF भी आप कर सकते हैं. R is the radius, तो इसको हम 20/100 कर देंगे in order to convert it into meters. And omega is 20 pi. अब आप इसको सॉल्व कर लें तो आपका आंसर आ जाएगा, राइट? आई थिंक इट्स 12.6 मीटर पर सेकेंड. और अगर आप एक्सेलरेशन निकालें, एक्सेलरेशन इज r omega square or v square over r, जो मर्जी आप, whatever formula you choose, you can apply omega square r or r omega square. Omega is 20 pi whole square. R is 20 over 100. इसको आप करेंगे तो आपका आंसर आ जाएगा. ठीक है, you can use any formula and you will get the same answer, right? ठीक है जी. हमें different examples नजर आती हैं circular motion में, which we will study. एक तो आपके पास बड़ी important एक example है जब for example एक object string के साथ move कर रहा है. ठीक है, it's like this vertical circle, right? So we'll study about this in this chapter, right? You have here a string all the way like this, and this is moving in a vertical circle, right? So object is moving with a string. Think of a string which is tied to an object. This is the object that we have. Number two, ये आपके पास अर्थ है और ये आपके पास मून है और इनकी जो आपस में ग्रेविटेशनल अट्रैक्शन है उसकी वजह से ये they are moving, right? This is also a circular motion that we have, moon and earth. Similarly, we have sun and we have earth, right? They're also, exhibiting circular motion because they are moving in a circle, and this is due to the gravitational attraction. We'll study this in the next chapter in a lot of detail. Gravitational force provides the centripetal force.
Everyone, I'm Cyrus and I teach core A-level physics. My session for May June 25 examination is going to start from 15th of October for O-level, IGCSE, AS level and A2. It's going to be a comprehensive, detailed 5-month session in which we're going to get a lot of practice from past papers, assignments, worksheets and quizzes. So what are you waiting for? Register via the link in bio and our team will assist you in registrations.